Okay, so I'm going to write down these definitions. Linear programming is a way to maximize or minimize a function. And that's going to be important if I'm trying to sell something. I want to know how I can get the maximum profit. It could be also how I want to get the minimum errors, kind of a thing. So you might want to maximize something and then minimize something. Constraints are going to be a set of inequalities and it normally makes a shape. If I throw some geometry at you, it's going to make a closed polygon because it's going to close things out and you're going to see how to maximize that or minimize it. And a feasible region is the region where all answers or solutions are possible. But the entire purpose of what we're doing today is we're going to take what you guys already just reviewed, which is a system of inequalities, where it all shades and crosses over is going to make a shape. So we're going to start where I actually give you constraints. Now, I could graph these on Desmos to go over how to do that. If I look at Desmos and I type in Y, and down here is my keyboard, you can see I have all the signs that are there. So if I type in 2/3 x minus 3, that's the first one. Then I'm going to type in y, use my keyboard again, it's going to be less than or equal to -1/2 x plus 4. Oh, plus 4's got to be on the outside. 1/2 x plus 4. Okay, do you guys see how I'm getting the shaded region where they overlap right now? We're going to do one more, and that's going to be x is greater than or equal to -6. So if I want to look, move down my keyboard, what I see here is this triangular shape. Do you see this big triangle? These are my corner points, and I just clicked on them so that they show up. If I wanted them to be labeled, I could screenshot this to put it in, let's say, a Google slide, which you guys are going to be doing later. But that's what my graph looks like. And it's simply asking me what my corner points are. So if I go back to here, we've already seen the graph. I'm not going to copy it again, but it's 6, 1, -6, -7, and -6, 7. And those are my corner points, my vertices of that triangle. So if you see, I have -6, 7, 6, 1, and -6, -7. Those are the vertices of that triangle. So if I wanted to draw it real quick, I could do the exact same thing. I would draw 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, -7, and 6, 1, 2, 3, 4, 5, 6, 1. And then I would just draw in my beautiful triangle. And just because I enjoy the highlight feature, I would highlight it in. So once I use Desmos and I get my corner points, it makes it a little easier for me to draw. It's a connect the dots and shade in between. So that's what I'm going to do. I'm going to be given a list of constraints, draw a picture, and then I'm going to have to maximize or minimize that. So if I move on to the next one. Now, what is an objective function? That is a profit or cost function that I maximize or minimize. So that means I need to have something to see what's going to be the biggest or the smallest, how to profit or how to do that. So here you'll see I'm going to fill in a chart. There's my objective function. Now in the last example, I had 3 corner points. I'm going to copy those exact corner points down. And you guys are going to see this chart in your project later. You're going to see an example of me doing it in a minute. But here's my objective function. It gives it to me. P equals 2x minus 3y. So I am going to plug in into all of this 2x minus 3y. 2x minus 3y. 2x minus 3y. And then I'm going to go back and say, well, what's my x value? 6. What's my y value? 1. -6, -7. -6, +7. And I'm going to plug that into Desmos or my graphing calculator just to get the answer. Plug it in exactly like you see it. And you'll see 9, 9, and -33. So it wants, does it want the maximum? Oh, I even put that in the wrong spot. I put the objective function. That's okay. What's the first thing it says? The what? Got to read. The minimum value of the objective function is what? What's my minimum value? -33. This occurs when x equals what? What's x? -6. What's y? +7. Because I'm going to highlight it for you. That's my minimum value. And what point is that? -6, 7. So that's where my minimum occurs. So in math, it's, never as straightforward as that most of the time. We're going to give you a word problem. And from that word problem, you're going to have to figure out your constraints and your objective function. And you're going to have to define your variables. All of these have an x and a y. So I'm going to read this, and this has no objective function in it. It literally just has constraints. So you can work at most 24 hours next week. You need to earn at least $168 to cover your weekly expenses. Your dog washing job pays $5 per hour, and your job at CVS pays $7.25 an hour. So I have 2 jobs. I work at CVS, and I'm a dog walker. I am looking for 2 things that I have to compare somehow. So I have 2 jobs. My first constraint deals with this right here. And these are the hours at that job. So how many hours can I work at most no matter what job I'm doing? 24. So no matter what job I'm doing, doesn't matter whether it's X or Y, I can work at most 24 hours. I can work 24 hours, but it has to be less than or equal to. Because I can work 23 hours, I can work 22 hours, but I can't work 25. So it's going to be less than or equal to 24. My next constraint deals with how much money I have to make. I need to earn at least $168. Can I earn 167? No, I'm going to be on a street corner pedaling, right? I just need $1. I need to have $168. Well, how much do I make at CVS? $7.25, and I make $5 an hour walking a dog. So $7.25 per hour at CVS plus $5 per hour as a dog walker has to be greater than or equal to 168. So those are my two constraints. There are actually two other ones that are implied. So the implied ones, which are pretty important to remember. Can I ever work negative hours? No, I can't. Most of these real life solutions, I can't go back in time negative. Time is continuous and it starts at 0. I can't go negative. So I also know that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. That's always implied. So you're going to need to know that to get that region sometimes. If you don't have those axes as your endpoints, it's going to go on and on forever in the negative. So it's pretty important to get that done. So the next thing they're going to go over is we're going to put some of this together. I'm going to already give you a shape. So what are my corner points there? And if I give it to you, you can use Desmos to graph it and see if you're actually getting your points right. This point, for example, is 3, 5. And sometimes people make a mistake and put 5, 3, but if you put it in Desmos, you can see that you're wrong. So just kind of make sure you have your x going first and then your y. 3, -3. This one's -3, 3. Notice it makes this nice trapezoid shape here. -3, -1. And those are my corner points. I'm going to write them down. And we're going to take a break and finish this up after lunch. I will write these down before you get back.